Hi, welcome back to Almy 14 Presents. My name is Mark. Today I'll be showing you how you can build your own game setup. And I'm not talking about a computer, but I'm talking about an actual game. We're going to build a rig, some sort of rig, I don't know yet, we'll see later. And it will hold several staffs that will drop down randomly one by one. And while standing underneath it, you need to try to catch them. That's the game. So let's get started. Okay, so let me walk you through the schematics. Okay, so the schematic is not complicated. I know I always say it, but it's true. We have a power section, and I will feed that using a 12-volt power supply, a NAT adapter, or if you're outdoors, you could even use a battery, a switch to turn on and off, and a standard regulator to create 8 volts that I need for the relay to give it a powerful kick. I'll get to that in a minute. I know it's not the most elegant regulator nowadays, but it's analog and it's proven and tested to work, so that's why I use it. We have our Arduino Nano, and the Arduino Nano has a push button that I can use to start a new game, or I can even give it a double function, for example, to put the system in an advanced mode for a more difficult game. And then we also have a LED to indicate if an advanced mode has been activated. We have a sound section, and basically that's a PMW or PWM, I must say, pulse width modulation, sorry. That's used to drive a speaker and is only used to generate a beeping sound to indicate the start and the end of a game. And it'll do the job quick and dirty. Then we have our relay drivers, and same here, a transistor that will switch a relay. The relay is actually the one holding the sticks to drop, and I use a door latch relay for that, and I did it 10 times. I only drew 2 in the schematics, but of course we're going to create 10 because we have 10 sticks. Okay, so let me show you the components. Okay, so we have our Arduino Nano. We have 2 sockets to install Arduino Nano. We have a push button and a power switch. We have some resistors that you see here, our transistors, the power regulator, a speaker, the LED indicator, some diodes. Universal diodes will do. This is to protect the transistors from the spikes that are generated by the coils that you see here. We have some capacitors, a connector, and yeah, well, these are actually the locking mechanism that I will show you separately. This is what we're looking at. Goes in here. And then when it's powered on, this will happen. Yeah. Simple as that. I put on the power, and then it's hanging like this, and the stick that's attached to this handle, it will simply drop. And of course, we're going to put all of that on a nice universal PCB. So it's time to start heating up the soldering iron, and let's get to it. Okay, so first things first, I'm going to put the headers on the microcontroller, and then I'm going to insert that there. I already made the power section, which basically is a regulator, the switch, and a few capacitors, and that's enough for the power. And I also placed a connector with a resistor, which is for the LED. And honestly, it's already on the board because I forgot to turn on or forgot to press the record button when I started. So sorry for that. For now, let's continue. The push button is connected to D2, and the neighbor of D2 is ground, so that way I can just pin the connector down and use the traces that are already on the plate. Okay, so Arduino, speaker and power supply are done. What's left are the drivers. And let me start by doing the resistors on the ports, because that's the easy part. And we start at pin whatever, 12, D12. We start at pin D12. I know this is not the most elegant way of soldering, but I have to make do with what I have at home. Yes, the soldering might look a bit chaotic, but I promise you that will all be fixed under a microscope later. Now I'm just going to remove some of the wires so it's easier to solder the rest under the microscope. Okay, so we're going to put the transistors. We have 10 of those. Like that. And then after that I can align everything. Okay. So those are almost all the components. Still need to add the diodes. Almost forgot about that. That would be a pity. Okay, so all components are on the board, which means I will be moving it to the microscope to finish up the soldering. At this point I'm using a Dremel tool to remove some copper that I don't need, and if I don't we will have a big short circuit. So this needs to be done. You can just follow the schematics, and of course it depends on your layout, where you put your components, and then you have to see which traces needs removing. Okay, so for this project I have to use some wires, because I didn't design a PCB and you know the traces are not there, so I have to make the connections manually by using wire. I have some fine wires, and all what I'm doing here is connecting all the dots, and you know, you just follow the schematic again like with the traces before. Follow the schematics and you'll be fine. I first encountered this game in a TV show long ago, like 20 years ago. We had something called the Honeymoon Quiz, very popular show on TV, and this is where I first saw a setup like this, and I always figured at some point I will have to build one. I'm going to have lots of fun with this, especially with the kids at my youth school. They can play with it whenever we have an event, and I'm sure we all have some fun. Okay, so I made a base plate with my 3D printer that I can use to mount the PCB on the speaker, the LED and the switch, to keep wires short and compact, and then all I need to wire up with longer wires are the actuators. I will do that in a bit. We'll start with the PCB first. Okay, so this is the base plate. I have two old spacers that I used in the spectrum analyzer, and I don't use them anymore, so those are nice to be used as spacer. We'll put them here and here, and then all I need to do is screw on the PCB. So let's start with that. Oh yeah, that was to be expected. Like so. No, I expect it to fit. Perfect. Like so. Okay, so let me attach the wires to the speaker, the switch and the LED, and then we'll move on to the aluminum frame. Okay, so let's start with the wires for the switch. So there we have it. That's the PCB with the wiring, like so. So here we have it, the assembled PCB with the basic wiring, the speaker, the switch and the LED, and of course all we need to connect is the actuators, and we do that to that connector. It has one common power, and the rest, each pin will be connected to a actuator. Okay, so now we are going to assemble the actuators on the frame, and you can build your own frame. You can use some wood bars or whatever you have laying around that can make a frame. It's not that spectacular, but I happen to have aluminum frames laying around from an old table that I had from my laser cutter, and it's called an item frame. And we're going to have two stands and a top bar on top, of course, which is going to be this one, and this will hold all the staffs that will drop down. So for the time being, let me put aside the stands and let's focus on this one. Okay, so this is where the electronics is going to rest, and we might as well do that. Slide in two of these nuts, especially made for this frame. Of course, it's a test setup. When I'm going to use this on a fair or some children's party, of course I will put a casing over the electronics and make it all nice and tidy. But for now it's an experimental setup, let's call it that, a prototype as you will, and for that this will be good enough. Now we're going to mount the actuators, and I do have to mount them somewhere like this, and then several on the whole rail. And then later sticks will be attached here, and it can drop. Okay, to attach these actuators I'm going to use double-sided tape. Make sure you use proper double-sided tape that can hold a lot of force, because you don't want the actuator to fall off completely. You only want the stick to drop when it's when the program says so to do so. So I bought some new tape that has some nice force. It says about 70 kilograms per square meter. Well, we don't have a square meter, but we still have a lot of force left, because what we are going to use to drop are these little wooden sticks, and they're not that heavy. Now, before you attach the tape, make sure you clean the surface with some sort of alcohol to remove any grease that's left, because it will help you with the tape. Do the whole railing. Yeah, like so. And now I will have to clean all these little, well, they're not really little, are they? The good thing is, all I need to worry about later is which wire is the common, and all the other wires I can just connect randomly, because the actuators are controlled randomly. Okay, so let's connect the actuators, or the wiring of the actuators, to the actual PCB. Well, the most easy wire, or actually the one wire that has a dedicated pin, is the power. Yep. And then I'm just going to do the last one. So the electronics is all done. We still need to do some mechanical work, which is attaching the clips to the stick. for it to properly work later. So now with all the sticks ready, it's time for some testing. As you might have guessed, the space in this room is kind of limited. The ceiling is up here, so I cannot elevate it too much. So for the test, I'm just going to kneel down. That's a failure. Crap! You're going to be mine. As you can guess, this is more difficult than I expected. Great! See you next time. I'm going to have lots of fun with this. So this is all I have for you today. I hope you enjoyed it. Remember, we have a project page at the Element 40 community. All the information you need to rebuild this project is there. And of course, you can leave comments or make suggestions about the project. And as always, I'll do my best to answer each and every one of you. Until then, I see you next time.